Good day to you, my dear students, and welcome to another week of Chemistry with Mr. Miguel. This week we will continue our discussion on mixtures, but we will focus on the topic of solubility. These are our objectives for this week, but we will start with the most basic, which is common definitions for common terms in relation to solubility. Solubility, according to the slide, is defined as the mass of the solute that will be able to dissolve and saturate 100 grams of solvent at a given temperature. Now, this in theory doesn't make any sense for me, so it is better if I can explain using an example. Solubility is how much of the mass, so look at the picture there, how much of the mass can dissolve in 100 grams of water at a certain temperature. That is more or less what solubility is. How much mass can dissolve inside of 100 grams of water at a given temperature. Very simple. Now go back to the definition, try reading it, pause the video, and then try to make sense out of it. Please take note of those words that are in red. For example, solute, dissolve, saturate, solvent, and temperature. What do they really mean? These are technical terms that we will utilize, so I will ask you to remember the definitions. So these are the definitions of the words highlighted in red in the previous slide. The first one is solute, and a solute is a minor component of a solution. Mr. But what does that mean? It means when you mix two substances together, the one that contains less, that is the solute. Now dissolve. According to the slide, to dissolve is the ability of a solute to disappear into a solvent. That means that when you add salt into the water, eventually you notice that the salt disappears because it dissolved. I need you to be very careful, because dissolve is not the same as melting. I have been seeing that problem from the first few weeks of classes, where people are using the word dissolve and melting like they're the same. They are not the same. Melting is a change in the state of matter. Meanwhile, dissolve is just disappearing within a solution. The next word is saturate. And saturate is the point at which no more solute can dissolve into a solvent. I have a slide specifically for this, so I will skip explanation for saturate. Solvent is the major component of a solution. So when you mix two substances, the solvent will be the one that contains the larger portion or the larger percentage in the solution. What is temperature? Temperature is not the same thing as heat. Okay? Temperature is not heat. Temperature is just a measure of how hot or how cold a substance is. Objective number 2. It's to explain the process of saturation of a substance. According to our slide, saturation is a process in which one substance can no longer take in more of another substance. And saturation tends to be an elegant word for a process in which you can't take it anymore. And the best example that I can come up with, or the best comparison that I could come up with for you, is that of a sponge. Let us say that you spill water on the table and you have a sponge on your hand and you are wiping away the water, and you notice that all of the water is sucked into the sponge. But there reaches a point when no more water can fit inside of the sponge, so nothing more can be absorbed. That point is known as a point of saturation. So in a sense, saturation is the point at which one substance cannot take any more of the other substance. And When we apply it to solubility, saturation would be that point where the solvent can no longer take any more solute, so the solute cannot dissolve into the solvent.
Take a beaker and dissolve some amount of salt in it. Go on adding salt to the solution. As long as the salt is dissolved in water, the solution is an unsaturated solution. But a stage will soon come when you will not be able to dissolve more salt in the solution. At this stage, the solution becomes saturated. Thus, a solution is said to be saturated if it cannot dissolve any more quantity of the given substance in it.
I will speak a little bit more about saturation later on in the presentation. One of the things that is important for you to remember is that solubility of one substance changes in different temperatures. So the solubility is not one number or one value. It changes throughout change in temperature. And in solutions that are made out of solids and liquids, the solubility changes in favor with temperature. So there is a positive relationship between solubility and temperature. This means that as temperature increases, so does solubility. In gases, on the other hand, the relationship is negative. That means as temperature increases, the solubility decreases. And we won't talk about mixtures or solutions of gases in this presentation. We will focus only on solutions made from a solid and a liquid. Now let me try to connect solubility, temperature, and saturation on the same slide. Let me tell you a story. I like drinking lemonade. I can drink lemonade every single day. But the way I do lemonade is a little bit different than how you would do lemonade. Normally, I will mix the sugar with my water first and then add the lime. But I've noticed that whenever I mix sugar with cold water, the sugar doesn't dissolve into the water. But when I try it with warm water, room temperature water, the sugar dissolves perfectly. It disappears into the solution. I'm using the same quantity of water, I'm using the same quantity of sugar, but why is it that the sugar does not dissolve into the cold water? And why is it that it dissolves in the warm water? Well, this illustrates that temperature affects the solubility of a substance. And I know that my solution is saturated when no more sugar can dissolve into the water. That's when I know, hey, this is saturated already. And if I change the temperature, the saturation changes, the solubility changes. And this is more or less how we can see solubility, saturation at home. And one of the things that you need to keep in mind is that normally we use water as our solvent. There are other types of solvents, but in this case, or in this presentation, we will be dealing only with water. Since we will be dealing with water, and looking back at the definition, it says that how much solute can dissolve and saturate 100 grams of water. And sometimes I just feel like this definition slaps my face. Why? Because it says 100 grams of water. We don't measure water in grams, we measure water in milliliters. So let me give you a brief conversion here. 1 gram of pure water is equals to 1 milliliter of pure water. This means that if we have 100 grams of water, that is equivalent to 100 milliliters of water that we can measure in a measuring cylinder. We can also measure it in a beaker. So it's easier to measure in milliliter. I apologize for the definition. Now I have shared a little bit of how I have observed solubility at home with my sugar mixture. And I've told you that solubility and temperature have a very intimate relationship with each other. But how do we know for sure? How do we know experimentally and scientifically that yes, solubility and temperature have a relationship? Well, let me give you this experiment that we conducted at school. So just for the record, the solute was potassium chlorate and the solvent was water. So what we did is that we prepared these solutions. So I had 5 beakers and Mr. Kelvin ensured that all of the 5 beakers were at different temperatures. For example, this beaker was kept at, if you notice, 10 degrees Celsius. This beaker was at 20 degrees Celsius. This beaker was at 30 degrees Celsius. This beaker was at 40 and this beaker was at 50 degrees Celsius. And guess what we did? We then added salt to each beaker. But in this beaker, we added grains of salt. And we noticed that it took 4 grams to saturate this solution. What does this mean, mister? This means that after we added the 4 grams of salt, when we added an extra little grain of salt, that grain of salt could not dissolve any longer at 10 degrees Celsius. So 4 grams was all that it took to saturate this solution. Then we moved on to the next beaker and we added salt to it. The name of the salt is potassium chlorate. And we noticed that, yes, we added 6 grams of salt. And this could dissolve 6 grams of salt. Remember that the previous beaker could only dissolve 4 grams of salt. Now at a temperature of 20 degrees Celsius, now it can dissolve 6 grams, but it could not dissolve more. 6 grams was all it took to saturate the solution. That means that even if I added 1 extra grain, that grain would not dissolve. Then we moved on to the next beaker. And in the next beaker, we added salt again. But this time, we added 9, 9.5, 9 3/4. We reached 10 grams. We added 10 grams. And if you notice, the values are here. We added 10 grams of salt. And it took 10 grams of salt to fully saturate this solution. So what is this showing? As the temperature is increasing, the water is able to hold more salt. This is the relationship that I need you to see. This is the relationship that I need you to understand. At a temperature of 40 degrees Celsius, now it is getting hotter. We added the 10 grams. The 10 grams fully dissolved. We added 2 more and it fully dissolved. We added 2 more and that is when we observe, hey, I think we've reached saturation point. We managed to saturate the solution at by adding 14 grams of salt. Wow, this is amazing. Then we moved finally to the next beaker and we added the salt there. And this beaker was at a temperature of 50 degrees Celsius. At 50 degrees Celsius, we noticed that this solution could take 18 grams of salt. So it took 18 grams of salt to fully saturate this solution. Do you see what is happening? As we are increasing the temperature, the solubility of salt actually increases. How do we know? Something that I need to make abundantly clear is that we know that we have reached the saturation point When we add 1 grain of salt and it no longer dissolves, that is when you know, hey, you've reached the saturation point. At different temperatures, we will have different saturation points, different solubilities. So we got all of this data, we have all of these numbers, we have all of these pictures, we have all of this evidence. Now it is time to demonstrate the relationship between solubility and temperature variation in a graph. And let me show you how we plot this graph. Here is how we would plot this graph. And we used the temperature and how much salt could actually dissolve in the water. So at 10 degrees Celsius, we noticed that the solubility was 4 grams. So our first point, we plotted it right there. Then we noticed that at 20, when we increase the temperature to 20, so we put our little point there, it could dissolve 6. At 30, we notice that it could dissolve 10. This is how, so we plotted first. How we did this graph is by plotting the points first, and after plotting the points first, we managed to construct this curve. This is known as a saturation curve. We continued the experiment and we got more data than I showed you. The slide could only have 5 beakers, so that's why I limited. But we actually did way up to 100 degrees Celsius to see if it changed. And we noticed that as we increase in temperature, the solubility actually increases. So this is known as a positive relationship in a graph. And we are able to use this solubility graph for many, many things.